Janowski. I'm a principal solutions architect here at Amazon Web Services. And in this session, we're going to do 3 different talks for you, actually. So I'm going to talk to you about ChatOps, and I'll explain what that is in a minute. And then Jack from Interactive Intelligence and Justin from Evan.io are going to talk to you about how they do DevOps at their respective companies. So let's get started. So how many of you here use Slack or HipChat or IRC? It's a pretty good portion. And how many of you use it not just to chat, but also you have a chat bot, or it gives you some feedback about what's going on in your environment? Okay, so a few of you. So that's essentially what ChatOps is. ChatOps is an approach to communication that allows teams to collaborate and manage many aspects of their infrastructure, code, and data from the comfort and safety of their chat rooms. Why would you do this, right? Well, what's the point? Well, it provides visibility into operations to anybody who has access to your Slack. That's a double-edged sword, though, right? So you want to be careful because depending on how you have your ChatOps bots set up, you don't want just anybody to log into your chat room and say, hey, like shut down all my instances or delete all my data from S3. That'll be bad. So you have to make sure that you get your who can actually access your chat down right. And there's a lot of solutions out there. So Slack, HipChat, they're all highly extensible. They often have integration with Lambda, which is our serverless compute platform, and they have integration with third-party services. So things like PagerDuty, Jira, New Relic, GitHub, you can all pretty easily integrate all of them. And so it's also easier than IRC. So IRC is great if you're like a developer, if you're like a hardcore computer nerd, but if you try to get somebody who's not technical to use IRC, it's probably not going to turn out very well. So whereas Slack and HipChat and these modern chat solutions are very user-friendly, you can access them from your iPhone, you can access them from a web browser. They're not behind a VPN traditionally, so I don't have to be in the VPN. I can access them from any web browser, and I can access them easily from mobile devices. Lastly, there's definitely built-in archiving, so I have a transaction log of what's going on. There's easy dissemination of screenshots, attachments, files, and it makes incident response much easier to handle. So you can enable guest access and bring in, let's say a vendor you're working with has an issue, you can bring them into your chat room with all your operations folks. So let's switch over to my actual screen, and I'm going to show you a little bit of a live demo. All right, so just some examples from what some of my customers are doing. So this is Datadog. This is one of our partners, and they can just pull up metrics in their Slack chat. So this shows their client latency metric, for example. Here's an integration with PagerDuty. So PagerDuty is this partner that basically what it does is you can keep an on-call rotation in PagerDuty, and it knows if you have a signal from your monitoring system, who do I call, who do I text, how do I escalate this? So it has interaction with Slack as well. So you can see, hey, something broke. I'm going to acknowledge this incident. Here's how I do this. There's integration with GitHub. So you can configure it so that it notifies your Slack. I'm using Slack for all these examples. Whenever there's a new commit in your chat room, you can do some kind of scary stuff in this as well. So in here, I'm actually talking to a database, and I'm doing a profile command. So basically profiling how long it takes to do a select star from my users table. So this is one of these things you have to be kind of careful with. And doing this is pretty easy. So in Slack, I'll show you how to actually do this soon. But you can configure slash commands, and these slash commands then can interact with specific URL endpoints. They can interact with Lambda functions. And you can also interact with AWS. So AWS has a service called CloudWatch events, for example, and I'll show you how that works. So let's take a look at some actual examples. So this is my demo Slack, right? I've got a bunch of stuff in here. So the first thing is I have something called CloudWatch events. So CloudWatch events basically almost immediately notifies me when something happens with my AWS account. So I've configured a CloudWatch event rule, and what this rule says here is, here, let me make this a little bit bigger. It says that anytime anything happens in EC2, and anything that is an instant state notification, I want to know about it. And the target is a Lambda function. And this is a Lambda function that I basically found off of GitHub. And it's a Lambda function that notifies my Slack. So let's see how this actually works. So here, this is my AWS console. I'm going to take one of my instances. It's a demo WordPress instance, and I'm going to terminate it. Let's see what happens here. So I just terminated my instance. Let's see. Did I get logged out? No, it's actually terminating. Here we go. And I already have a notification in my Slack right here. So it's saying your instance is shutting down. So I've had it. So that happened really fast. It was almost instantaneous. So I have almost instant visibility into what's going on with my chat room. Let's take a look at some other stuff. For example, let's take a look at how this actually works first. So this is a Lambda function, right? So again, I pulled this off of GitHub. And so this is some Python code. And it's pretty, actually this one is JavaScript, I think. It's pretty simple. And all it does is, wait, this is the wrong function. Sorry. Here we go. Notify Slack. This is it. So yeah, this just has a token to talk with my Slack chat room. It says what channel to talk to and what username to take and to pass along a message. So this is a super, super simple Slack function. So let's see how this actually works in Slack. So here is some examples, some configs. So here's another one. This is a GitHub integration. And so basically I have configured it so that in my GitHub account, for the following 3 repositories, for any branch, although I can configure specific branches, I will get notified when the following events happen in this chat room. And so this is a built-in integration into Slack, for example. I don't have to do anything custom for it. So I have a Git repository here. I'm going to change a README file. Let me see if I can make this a little bit bigger. There we go. I'm going to add some exclamation marks. I'm going to add a really descriptive commit message here. I'm going to push this out. And I've pushed this out to GitHub. And again, let's check my chat room. Again, immediately I get a notification that I've changed something in Slack. And I also get a notification that my instance has finished terminating. Let's take a look at some other stuff we can do. So we can do slash commands. So slash commands means when I enter the following command into Slack, it will talk to this specific Lambda function. Now in this case, I'm using our API gateway service, and the API gateway service is proxying to the Lambda function. So I have 2 functions here. I'll show you one of them. The first one just echoes back whatever I type to me. So it's just a simple test function. The second function here, build WordPress, what that does is it actually kicks off Jenkins and kicks off a build of my WordPress. So this kind of thing, though, you have to make sure you have really good authentication on because, again, it's interacting with Jenkins, which probably has a lot of privileges. So you got to make sure that's set up properly. But let's see how this works. I'm going to go here. I'm going to type in build word, or actually, no, I don't want to do that one. I'm going to do Lambda test. Testing 1, 2, 3. And here we go. It just echoes back what I wrote to me. So it says testing 1, 2, 3. So that's triggered a Lambda function, and it's given me output. Now, the cool thing about this is running off of Lambda. There's no instance that's running this function. It's running for a few milliseconds. It costs almost nothing. So you can do a lot of cool stuff with that. Let's take a look at some other stuff. So you can do the inverse. So the first thing I showed you was a slash command. So I type something into chat, and it triggers a Lambda function. The way that the CloudWatch events works is the opposite. So it's an incoming webhook versus an outgoing webhook. So CloudWatch events, it triggers this Lambda function that I showed you earlier. The Lambda function goes through this incoming webhook that I've configured, which has API keys, or actually, here we go. It has a webhook URL, and that's how I get it into Slack. So that's the opposite. So that is some really basic stuff I can do with Slack. Let me show you another cool thing. So there's something called Hubot. Hubot is a chatbot. It's been around for a while, and you can configure it with all sorts of cool integrations. In this case, I've configured it with a pretty scary MySQL function. But let's see here. So I forgot the commands, let's say, so I can type in a command to get help. and my Hubot is called Picard because I love Star Trek. So I'm going to do a MySQL profile command, and I'm going to profile, which just shows like how long a certain MySQL command takes. Select star from WP users. And oops, I messed something up. I forgot a semicolon, and I forgot a from. There we go. So it basically gives me the output of a MySQL command. The last thing I'm going to show you is this thing called Yobot. So this is pretty cool. So Yobot is basically connected to my AWS account, and I can do SQL queries against my AWS account. So I can do things like select the public IP address from a specific EC2 instance with a specific tag. So I'm going to do that, and it's going to output, there we go. It's going to output the IP address of this EC2 instance. I can do all kinds of stuff here. I can just do select star from EC2 instances. They're going to show me all of my EC2 instances in my account. So here we go. Here's an example showing me all this metadata. So ultimately, this is very extensible. This is just a small peek of what you can do, the kind of cool interactions you can have through chat, and you can increase visibility into your operations. And there's a lot of tools out there that can enable you to do this. So now we're going to have Justin come up and talk to you about DevOps. Oh, Jack. There we go.
Good job, Leah. How's everyone doing today? Good. Okay. You're not going to learn anything here, so I'm going to apologize right now. So I'm going to talk a little bit about operations and specifically about DevOps. A little bit about me, my background. I've been in this industry for about 15 years now. And prior to 2 year ago, it was all in infrastructure. So about 15 years ago, I was a little bit skinnier. I had less gray hair, and I probably drank a lot less. So really, I want to talk a little bit about really kind of my personal view of how getting out of operations hell. I mean, we've all been there. We've all had to work to keep the lights on. And, wanted to kind of talk at the beginning of just my personal story, what I've seen at the places I've been throughout my career. So, really walk through what I've seen, how I've seen the industry evolve, and kind of where we are today at Interactive Intelligence when it comes to DevOps and our deployments and uptime. So if you'll travel all the way back to 2003, which I see a few people that probably might not have been alive then in the back of the room, I started my career at a company called E-Trade. So for those that aren't aware, E-Trade was a technology-based trading company, very well known for their $2 million waste of money for a monkey clapping on the Super Bowl ads. It was a great place, though. It was a great place to learn, and it was the first real true global kind of .com environment I was in. But one thing back in 2003 was everything was physical. So I see a lot of people that had probably worked at that time. You didn't have virtualization. That was not even a thing back then. Everything was physical. So you had thousands of servers that were actually physical boxes. Today you go and everyone's like, oh, I got thousands of servers, but they're all VMs running in EC2 and running on their own virtualized platform. But we actually had thousands of servers that were physical, which also means that you're always looking at what's my uptime, what happens if something fails, what's my mean time between failure, and you're always having to manage those boxes. And what that meant, for those that aren't familiar, that's called a pager. Not pagerduty.com, but an actual pager you had to wear because something was always failing and we always had to notify people because we existed in an operations realm to make sure services stayed up. And we worked in these dark caves called NOCs. And that's not actually the E-Trade NOC because they wouldn't let us take pictures. And again, we had no camera phones, no Twitter, no Facebook, all that stuff. But basically, this was staffed with people 24/7, and all they did was, make sure that we mitigate failure. So if when those physical devices failed, we got to make sure the site's up, it's available, people could trade. We got to then investigate if something breaks because it was physical. It wasn't like we just threw it in the trash. We had to figure out why it broke and then fix it and get it back into production. We also had to do all those mundane tasks that we all kind of take for granted today. So I'm going to throw a couple numbers and see if anyone have a guess what 12, 24, 35 is? Anyone? Don't be shy. No. Yep. So to give you an idea, so this is back 2003. It took us 12 hours to update the E-Trade website. So we had 2 shifts of people that worked nonstop throughout their shifts just to update all those physical servers for the E-Trade website. And because of that, we only did it every other week. So you can imagine, we were slow to get changes out. We seemed fast at the time. It was like, everyone's like, wow, how'd you get that done so fast? We could only do emergency changes, if someone messed up a phone number, which happened very frequently, which usually went to very interesting places when they messed up the support line. And then on the network side, where I spent a lot of my time also, was we had to change our passwords basically every 45 days, or if someone left the company. So we actually had to spend 24 hours, 3 shifts of people, logging into every physical network device, changing the password, and then re-logging in to verify it. Talk about the most boring, tedious thing you could possibly do. And we were staffed with 35 people. That doesn't include supervisors and managers. So we had 35 people. That's all they did 24 hours a day in their life. And I see people laughing here that have probably been there. And that's what we spent all of our time on. And there was a large group of us that came in and started saying, really it was more out of the necessity of we were bored to tears of having to do these mundane tasks. We said, how could we make this better? And so we started playing with Perl, old programming language. Started playing with what was called Net Telnet Cisco, if anyone's familiar, Net SNMP. And started figuring out, how do we automate some of these things? How do we build Perl scripts to do all these kind of boring things that we actually never want to do again in our lives? On the system side, we started saying, okay, all these servers were all running Linux. Could we build a command center where we could basically run a single command from an admin node and push out code and make events happen on any node within that environment? And then we said, okay, well, once we had that working, we said, now could we start building batch scripts that could actually update the site? So by the time I left E-Trade, we'd actually taken the update from the website from 12 hours down to 4 hours through just those general basic scripting. This is all a bunch of young kids basically at the time. Well, I feel like I was a young kid back then. Working on these things at night and weekends and playing with them and figuring out how to automate these things. We took the network change down to half an hour. And that was basically because we had one script that went and changed it and one script that verified it. So we took all that mundane stuff we hated doing. We figured out how to just make the computer go do it for us. And we reduced, we were able to move down to operations. Now that wasn't all. We didn't just fire everyone, so everyone always freaks out about that. We found a couple of them new homes, and then a couple of them found new homes other places. So we were able just to really use those scripting and those pieces to really figure out how to make some of the basic mundane stuff a little bit better. And really what it taught me, and when I walked away and kind of thought about that from a DevOps perspective, was the idea of automation. How do you automate those basic mundane tasks that everyone does? How do you take some of these things that we just kind of almost sometimes get routine in and then figure out how to just make them a little bit better through simple tools. And today, if you look at the tools that are available to everyone, it's amazing when you look at the chatbots and things like that. You can build these things in minutes. So fast forward a little bit to 2008. We get a bit nicer TV, start getting flat screens. I worked for a global company called Brightpoint. They were a cellular logistics company, and they had about 42 offices in 26 different countries. So large network. Unlike E-Trade, though, it wasn't all in multiple data centers. It was spread throughout all those sites everywhere. And during that time, VMware started taking off. It was kind of my first experience of starting to see the power of server virtualization. But we didn't really virtualize in what I would call today's microservices architecture. Is more of take the big physical server, turn it into a virtual, and plop it down on another big physical server. Just try to get a bunch of them on there. But it was a very interesting concept, and it started opening some new doors. We also happened to be during the worst economic recession possible at that time. So what we learned was do more with less. So our team was basically managing the same infrastructure with half the amount of resources that I saw at E-Trade. And just fun fact, that's actually the Burj Khalifa on the top floor, so at least we got to do a few fun things while they were working us all the time. So some of the things I learned from my time at Brightpoint was really what we did to kind of how do we figure out all this infrastructure? How do we take care of it with a limited staff? So first thing we did was we figured out ways to standardize templates to say, okay, here's how each site should look and classify it. So we only had 3 sites that we said, okay, any site that looks like this is going to be the same. So A, B, C was always exactly the same. We also figured out how to automate those templates. So when someone said, hey, we're going to turn up a new warehouse in 2 weeks, we just went in and put a few pieces of information in, and we had the entire bill of materials, everything ready to go, and we could get the warehouse up in 2 weeks, which had been unheard of prior to that. And really, because we were poor, we started learning how to leverage off-the-shelf services more, which I think has become more and more. I think Andy talked about it this morning about the idea of leveraging all these services and bringing them together, that you're not going to be building the server anymore, you're going to be leveraging services across. And I started kind of seeing that. And really the big thing that I think came out of that was really that infrastructure. The idea of starting to virtualize the infrastructure, looking at how you could do that. And while we were just getting into servers, as everyone's probably aware, software-defined networking now has started to become bigger and bigger. So finally, in 2011, I actually got to go to a company called Interactive Intelligence, and they were basically starting what they called their first generation cloud. And so they had a first generation cloud, which was CAS, and really was taking their legacy software, picking it up, and putting it into data centers and more of a hosted model. But it was the first place we got to start taking all these different pieces that I'd kind of seen, the infrastructure virtualization along with the automation scripts, and figure out how to actually leverage that to do more of an operational DevOps approach. We also were in an extreme growth time. So when I started there, we had about 1,500 nodes, and by 3 years, we were up to 5,000 nodes and 14 data centers around the world. So leveraging those, we were able to scale very, very effectively. But it was very challenging still because we had a legacy architecture. We still had a lot of physical elements of it. And we started learning a little bit more and more about asset management. But moving forward to 2014, though, was kind of the first time I started really learning a little bit more about Amazon Web Services and really network virtualization, all those kind of pieces, the idea of EC2 and instances, and starting to change the idea of worrying about the physical nature, which has been fantastic, honestly, and starting to look at it. And the way we treat infrastructure nowadays is extremely different. The same concepts of how many servers do we have, how often do they fail, what's the mean time between failure. When I actually went to our DevOps director and asked him that, first thing he said, we don't know. And the second thing he said to me is, we don't really care. We don't care about that anymore. That's not a metric that's valuable to us anymore. It doesn't matter. And the reason is because when we look at servers, we don't name our servers. As he put it, he goes, they're not pets. They're not special anymore. They're commodities. If something has a problem, we don't try to fix it. We just say, okay, drop it, spin up a new one. So we don't worry about that. So we never have ever named a server. So even on like the chatbot example earlier that Leo was showing, we don't care if a server shuts down as long as all the other components say, oh, it shut down, make sure another one gets popped up there, all the code gets deployed. We don't care about that anymore. It doesn't matter. That happens all day long, and we have to build around it. We don't patch servers. This is a very interesting concept, and I know they were talking about security earlier. We don't patch any of our servers, ever. All we do is we develop new base AMIs, we put all the patches, all the security pieces, and we roll those out along with the application every week. So we never, ever go out and patch. It's actually been 10 times better, I can tell you, from having to run an infrastructure where we had to patch 5,000 servers and deal with all the customers that were very angry about patching 5,000 servers for compliance. The idea that we can get all of our servers out there, never patch them, and be more up to date than probably any place I've ever worked at is amazing. And then we also don't fix servers. Again, we treat them, they're a commodity. We don't name them, we don't fix them. There's a problem with it, shut it down, pull up a new one. Everything's from that. But what really enables that is the idea of moving from kind of, if you think about the monolithic architectures where everything's very tightly coupled, was we moved to microservices. So what we did is we looked at it and we said, okay, with all these concepts of automation and EC2 and all the different things that Amazon brings from a kind of a cloud OS model, the idea of build services that all interconnect, don't worry about all those pieces, we said we need to build the application with that. So we started saying, take everything apart, everything needs to be very disconnected. It needs to be its own microservice that talks in this overall kind of community of services to actually accomplish the task. And that's kind of what I think the third big piece I've seen in my career, and it's really starting to come about. You're hearing this more and more. You're seeing companies re-architect rather than just pick up and move into the cloud. Is that application piece really enables you to do a lot of great things. So when you actually pull all three of these together, so you take that virtualized, fully virtualized infrastructure, software-defined networking, EC2s, take all the elastic load balancing, auto-scaling groups, you add that with all the automation of the tools, Chef, Puppet, OpsWorks, all those pieces together, and then you have an application that's been architected for failure. When in a microservices environment, rather than saying, oh God, hopefully nothing breaks, it's like, no, just make sure everything breaks and nothing is impacted by it. Netflix was probably the first one I've seen that went out and did that with the, Chaos Monkey. So if you're familiar with Netflix, their whole chaos simian army of Chaos Monkey and Gorilla and Kong, the idea of, why would you ever do a DR test? No, we're just going to kill everything all day long. And so at Interactive, we actually kill every single service every day, at least twice. So every hour just starts killing these things off and basically flips a coin, yes, no, and kills it, and then we make sure that there's no impact downstream. So gets rid of that whole piece. So when you look at this, what it allows us to do is, any idea of these numbers? No one? I know it's late in the day. I know there's a tornado or something going on upstairs. At least that's what Google yelled at me for. So if you think about it today, so we actually do 200 code deployments every day. So you think about that. We actually deploy 200 code deployments to our various environments, probably about 20 of those into our production environment every day. So we do the idea of continuous deployment. Things that I heard someone talk earlier about, used to take years to get software out, even in our original software. By the time we envisioned a actual service, to the time we released it, to the time consumers actually started moving their software, because no one wants to update on the first release, because we've all been through that hell. And it'd take 2 years. So now, by the time we identified a need to actually be able to use it, was 2 years. We now see this time going down to 6 months. I mean, we had a bunch of customers come to us last August, and before the end of the year, we actually had an alpha test of a brand new feature we hadn't even imagined and envisioned at the time. Because the other thing we do with that is each of the microservices with that architecture, they're all independent, and they're all independent teams. So they actually can build their own microservices. They leverage their own databases. With leveraging EC2 and the different data services, we actually sometimes when we're bringing out a new service, we'll run 3 different database technologies to see which one performs the best, because some things need high transactions. Some of them need to be able to pull lots of data. So we'll look at those and actually evaluate them as we're going. So it gives that ability to experiment with the different services and different things that are more appropriate for the application. And today we have about 3,300 EC2 instances. A funny story, I finally, after asking tons and tons of people, I had to go to finance to look at our bill to figure out how many EC2 instances we actually had. They're the only ones that were actually caring about that, oddly enough. And we do all that today, so if you think about it, with 8 people. So if I look at it 15 years ago, we were moving slower, dealing with physical, not able to move a lot of stuff fast, and we were still dealing with 4 times the amount of people. So when you hear, so for me sometimes when, I was joking about the tornado, I thought. So if you think about that, I mean, we're doing 10 times more with 1/4 of the people we used to have. And at the same time, with our web services, we're keeping up everything at 4 nines availability around the world. We got rid of the idea of any kind of maintenance. One of the things that we always tell people is we don't have maintenance. We roll stuff all day long. If we take it down when we roll, that's considered outage. That's not considered a maintenance window like a lot of services where they say, okay, from midnight to 2, we're going to push code in there, and if it breaks, sorry, it doesn't count towards the SLA. It's like, no, we're doing this all day long. We're just pushing these things out, and we're figuring out ways to communicate it and setting feature flags and figuring out how to manage that. Because consumers, we were a little bit afraid about 3 years ago that it'd be hard in the enterprise space, but I think we've all become so accustomed to it as consumers that our phones now, they don't ask to update anymore. They just update the app for you. You log into your LinkedIn or any other service, well, except for now Microsoft bottoms, that might change. It's automatically updated and things work. Sorry, Microsoft, please don't fire me. It just changed that whole mantra. And really, it's enabled us to do a lot of things that we never thought were possible. It's allowed us to deploy around the world very quickly. With our standardized code pushes, we can actually deploy to a new EC region in about 45 to 60 days. And that's really because we have to get everything set up. We do the initial base install. We push the code up there. We get all the business elements, or actually half the time we spend the time, and we can get into that new region. So as soon as Canada's online, 45 days after that, we want to be up and running. As soon as India comes online, we're going to be up and running 45 days. And then when we push code, it just pushes it around the world to all those places in a very standardized fashion. So, kind of one of the questions I'll leave everyone here with is, if you think about your own journey and you think about the companies you work at and the services you're working on, where are you at in that time frame? Are you back in 2003? Are you in 2008? Are you operating in 12, 14? There's a lot of changes going on in the industry. I mean, we heard that earlier at the keynote. And to really think about, are you doing everything? What else could be done? Are you just picking stuff and moving it over? Are you looking at different operational things that you could do to actually make things more effective? And screw the hell out of that. So I'll leave you with my gratuitous self-promotion slide.
Hello, good afternoon. My name is Justin Lundy. I'm the co-founder and CTO at Evident.io. We're a Silicon Valley-based cloud infrastructure security company. And what I'm here to talk about with you today is what I like to call DevOps by the numbers. So what I'm going to do here, just kind of give you a brief synopsis of what I want to cover, is I want to talk about some statistics that some DevOps organizations have put together based on some surveys that they've done where they spoke with thousands of people around the world who are doing DevOps to ask them, how are you benefiting from DevOps? What does that look like for your organization? How does this differ from your traditional IT model? And then I want to also talk about how I've got some experience with DevOps. I've been doing it for about the past 4 or 5 years. And I have some war stories that I want to share about when I was doing security and DevOps at Adobe, and we made the company a couple $1 billion in our line of business, and it was all hinging on the fact that we were doing DevOps. So really what I'm covering here is how you can innovate faster and more securely than the competition by taking advantage of DevOps capabilities. So one of the most recent surveys out here that's worth mentioning is how, in Gartner's estimation, by the end of 2016, they're expecting about 25% of the global 2,000 to be using DevOps. But in our experience, based on all the conversations we've had with customers at Amazon reInvent and at this show, we think that number's actually low. And we're seeing it accelerate at a much faster adoption rate than even Gartner is seeing. I would say that about 80% of our customers are leveraging DevOps, and then the other 20% are talking about it and trying to figure out how to take advantage. I would also mention that if you haven't heard of RightScale's survey, they've done some interesting work too, where they found that in their sample set of people that they spoke with, 74% were already using DevOps. So that's not just global 2,000, that's small to mid-size and so on and so forth. And it's, in many cases, being adopted from the bottom up. So the guys that are doing the DevOps deployments, the guys managing the servers, are the ones pushing the technology. And what we found is it's really out of necessity. In our case at Adobe, we adopted DevOps practices and DevOps culture because the CTO of the company said, hey, guess what, everybody? You're moving to the cloud, whether you like it or not. And we had to figure out how to do it in 18 months. And so we spoke with a ton of people in the Valley, and luckily we hired some people from Netflix. And as you know, Netflix is one of kind of the leading organizations that kind of started building the DevOps culture. And we learned what they did to allow them to manage massive fleets of infrastructure on Amazon, and took advantage of some of those same tricks, and I'll cover some of those here for you. So another company, Puppet, they're also backed by the same VC that backed us, True Ventures. They found that their customers are able to perform in such startling numbers that it's almost insane. When you consider the fact that you take advantage of DevOps, and all of a sudden you're doing deployments 30 times more frequently, or you get your production deployments ready to go 200x more frequently than if you were doing traditional IT. That's really startling. It should give you an idea of why the interactive intelligence guys, for example, were able to operate such a massive fleet of infrastructure with just 8 guys. We have a variety of customers that have different frequency of deployments, but many of them operate on daily or multiple daily deployments, and that's only really possible with automation. That's not something you can do by hand. You can't hire enough people to move that quickly. When it comes to reliability, one of the added benefits that you see out of DevOps is a lower rate of failure, essentially. So when you're doing deployments, the more infrastructure you have as code, the more templatization that you're doing of your infrastructure, you'll see fewer mistakes take place, because the traditional alternative was you'd have people log into each individual system and apply some patches, and naturally people make mistakes. So when you automate a template and you roll that out and say, okay, now these 5,000 servers need to have this particular template, the margin for error just diminishes. In terms of performance, there's some benefits that you get here as well. And what's interesting to me is how the companies that adopt DevOps in Puppet's survey, they found that over time they had a higher market cap than their competitors, just due to the myriad benefits that they achieve as a result of adopting DevOps culture in their company. So, in my example, we had 3 key people in our Creative Cloud line of business that were kind of leading the DevOps charge, and we were kind of training the rest of the engineers on how to adopt DevOps practices. But by these 3 people kind of pushing the culture change, that's what allowed us to grow from our first Amazon account with 1 server to 10,000 EC2 instances operating in multiple regions around the globe, and millions of end users that we were providing the service to on a regular basis. So in a quick summary, when you want to look at traditional ops teams versus DevOps teams, it's only natural when you stop and think that traditional ops is more time consuming. You spend more time communicating to try and coordinate, when really you should just do as much of that automated in code as possible. We found that by spending more time on infrastructure as code and by ensuring that we were operating following kind of DevOps principles, it allowed us to spend less time responding to tickets and support requests because there were fewer problems. We were just inherently smoothing out the problems that you have in kind of day-to-day operations and management of your infrastructure by fixing the bugs as we went along in kind of incremental fashion in our code base. So these are some more statistics here. As soon as I get through the stat slides, then I kind of jump into more of how our company helps organizations that have adopted DevOps or are looking to adopt DevOps can take advantage of some of the benefits that are available when you're operating on Amazon Web Services from a security perspective. So naturally, you're going to see quality improvement, you're going to see faster deployments, you're going to see higher reliability, you're going to see greater performance. Your teams are going to cooperate more effectively, and you're going to have higher quality code with fewer bugs. I mean, I would challenge anyone in here to say that they don't want these things. The last point on this slide is how we found that DevOps is actually kind of, you can look at it like a force multiplier for your team. I know it's really difficult to hire talented folks right now that have Amazon experience and have security experience, but we find is if you provide your existing staff with tools that make them more powerful and more effective, that's kind of the force multiplier effect that we're talking about. So there are plenty of examples of federal agencies that are taking charge in terms of adopting DevOps and trying to demonstrate what's also possible in this side of the world. Everyone wants to move to the cloud faster. That's a given. And with the same benefits that the commercial sector sees, the public sector can just take advantage of as well. So what does Evident do for companies that are adopting DevOps or are interested in adopting DevOps? We provide a continuous monitoring platform that analyzes how customers are leveraging Amazon services. So whether it's EC2 or S3 or IAM or RDS, we take a look at how you're configuring all of your services. And we identify potentially exploitable misconfigurations in how you're using Amazon. And then we guide you through the process of mitigating these risks, and then also giving you the ability to automatically fix the problems as they happen with Lambda functions, like you saw during the ChatOps section earlier. So how are some of our customers in the space, in particular the public sector, taking advantage of Evident? So they're using Evident as a kind of continuous monitoring and self-assessment tool where not only the security teams in charge of the security for the infrastructures are using the platform, but also the DevOps teams are using the platform as well. So in the development phase of working on your applications before you go to a production deployment, you have Evident continuously monitoring, and it shows you, okay, this mistake was made over here in this service, and you want to make sure you turn on encryption there. Or this bucket has an ACL that needs adjustment because it's world writable and it shouldn't be world writable. Or you have this particular IAM user that isn't taking advantage of multi-factor authentication, and you want to make sure that that's turned on. We also, to follow the theme on ChatOps, we have integrations natively in the platform where you can leverage the data that we generate, and it'll feed that into a Slack channel for you, or it'll feed it into a HipChat channel, or it'll pump the data into PagerDuty. So depending on how you want to leverage the information, if you're more of a DevOps-y shop and that's how you drive things, that's one way to use it. We have a lot of people using it that way. Or if you're more of a traditional security-focused organization and you feed the data into a SIEM solution in a SOC and you have SOC analysts respond to incidents that way, that's another way that it can be used. It's intended to be flexible. So the point is really you want to address risks before they get to production. So your developers can quickly identify issues without having to have kind of a longer tail conversation with the security team. I found that in other companies where I worked, developers would get a system ready for production and they'd just be ready to flip the switch. And then that's when the security guys got called in and they would say, hey, wait, oh my gosh, you have 250 things to fix first. And then everybody gets mad and the deployment gets pushed out 2 weeks and nobody likes dealing with that. So what we do is we provide this information as the developers are moving along from day one, even when they launch the first server, and then kind of tweak the settings as they go. And it's more of an incremental, less painful thing to keep your infrastructure in compliance, rather than a more time-consuming, just prior to production deployment type of operation. So as you're using ESP to do a self-scan, you can use this information to help prep yourself before you try and achieve certification and accreditation. If you're looking to get FedRAMP certified at some point, or if you're looking to get PCI certified at some point, what you can do is you essentially take advantage of what the platform provides so that you are closer to where you need to be when you do that CNA effort later on down the line. One of the things that's important here too is how much time you can save by leveraging the auditing capabilities in collecting the body of evidence for how you're configured. How do your security policies look? What do your firewall policies look like? What does your IAM settings look like? How does your encryption look across your databases? Do you have backups for your databases and so on and so forth? All this is just automatically collected across your entire Amazon footprint, all regions, all accounts, all services on a continuous basis. So you can show up in the office at 9 a.m. on Monday morning and just dump all that information in a big spreadsheet and say, look, here's where we're at right now, even if you had a whole bunch of activity the week before. Now, one of the things that's worth pointing out too is we don't just tell you, oh, here's all your problems, like some other products, and hey, now go figure out how to fix it. We actually walk you through the steps you need to take to address any of the issues that are identified as they're identified. And not only that, but we have APIs that we've implemented that allow you to implement Lambda functions that'll automatically remediate the issues as they come up. So for example, really common example is, I never want to see an EC2 instance that gets launched with an R desktop port open to the entire internet. And the minute you see that, lock it down and notify me. So we have a lot of customers using it in that way, for example, and it's flexible. You can write a Lambda function that'll do just about anything you want, as you saw. It could send a message to Slack. It can lock down a firewall policy. It can, prevent an IAM user from logging into your Amazon console, and so on and so forth. So, the last thing I would say is, we're always interested in improving the product, and we do have a free trial. So if you're interested in kicking the tires, we'd love your feedback. And thank you.